Probability of question 6. Okay, if x is a geometric random variable and expected value x is given as 5. Okay, determine a the probability when x equals to 4 and the probability between 2 to 5. Okay, 2 to 5. Okay, let's do the first one. Okay, a when probability is x equals to 4. Okay, so we know the formula is expected value E equals to 1 over P. Okay, so from here we can figure out what is the answer. Okay, so just playing with the formula. So when x equals to 4, let's find out what is P first. So P equals to 1 over the expected value, which is 1 over expected value, which is 1 over 5, the same as 0.2. So P is 0.2. So if P is 0.2, Q equals to 0.8. Okay, so let's use the formula. So the formula is Q power of R minus 1 times by P. So Q equals to 0.8 to the power of 3 times 0.2, and the answer is 0.1024. Okay, 0.1024. Okay, next P. Okay, the probability of between 2 less than x less than 5. Okay, what's the probability? Less than 2 less than 5. Okay, now, okay, this is be kind of tricky. Okay, you must understand what are they talking about. Okay, what are they talking about? I'll just change color. Okay, the probability between 2 to 5. So what's inclusive between 2 to 5, excluding 2 and excluding 5? So basically the probability of P x equals to 3 and the probability x equals to 4. Okay, x equals to 3 and x equals to 4. Okay, what happens if I find when probability of x is greater than or equal to 5? What happens probability of x is greater than or equals to 5? Meaning there's no hit all the way up to 4. Okay, no hit, meaning the probability, the hit only start, or the success only starts after 5. Okay, hit or no hit, I'll just use that. Okay, so only 5 and onwards, so there's a hit. Okay, trial, nothing happens for the first 4, but the 5th, 6th and so on, there's a hit. Okay, so there's no hit first 4, so let's do that. Okay, so this is same as 0.8 to the power of 4. Okay, so I'll just write here no hits. Okay, so okay, we have done this question before. So if I take the complement of this, 1 minus 0.8 to the power of 4, okay, meaning all the hits, okay, all the hits inclusive of 1, 2, 3, 4, all the hits between 1 to 4. Okay, so this should be all the shots that hit, okay, between 1 to 4 inclusive. Okay, so meaning everything. Okay, so 1, 2, 3 and 4. So when I use the maths, okay, the answer is 0.5904 from the calculator. Okay, so everything that's probability of getting hit 1 all the way to 4, okay, inclusive of 4. So now what is the probability? Let's use the same method. What's the probability of x greater than or equals to 3? Okay, greater than or equals to 3, meaning there's no hit for first 2, 1, 2, there's no hit. So 0 point again q to the power of 2. So this is no hits. Okay, and the complement of that, which is 1 minus 0.8 to the power of 2, will be shots hit. Okay, shots hit meaning it's 1 and 2. Okay, so x equals to 1, x equals to 2. Okay, so now this is 1 minus that, the answer is 0.36. So just now we have all the hits between 1, okay, not between, inclusive, 1, 2, 3, 4, and then for x is greater than 3, we have a complement of that, we have 1 and 2. So 1 to 4, okay, so p x equals to 1 all the way to p x equals to 4. Okay, we have 0.5904, and then we minus this with the probability of x equals to 1 and probability of x equals to 2, okay, which is 0.36. Okay, so when I subtract that, 0.5904 minus 0.36, my final answer is 0.2304. Okay, 0.2304. Okay, that's the answer. Okay, next question. Okay, question 7. Okay, Carmen wants to take a taxi. Okay, I'm gonna write it over here. Okay, at the bottom, so that I can scroll up to see the question when I'm stuck. Okay, Carmen wants to take a taxi where she is 5% of the vehicle are taxis. Okay, the place that she resides, only 5% are taxis. X is the number of taxis that number of vehicles that she sees up to and including when she sees a taxi. Okay, up to and including when she sees the taxi. Okay, let's find this. On average, how many vehicles will she see up to and including when she sees a taxi? Okay, including when she sees a taxi. So the first question, how many vehicles will she see? Okay, so anyway, probability of getting a taxi is on average. Oh, okay, so this is an expected value. So expected value. So EX equals to 1 over P. So first of all, where she is 5% are taxi. So probability of she seeing is only 5%. So that's 5 over 100, 0.05. Not seeing 0.95. Okay, immediately the moment you get the value P, please write down what is Q as well. Okay, so 0.95. Okay, now the expected value, we already have the formula, so just sub it. Okay, P is 0.05 and my answer is 20. Okay, so basically on average she has to see wait maybe on the 20th vehicle is only a taxi. Okay, only on the 20th vehicle. Okay, B, calculate the probability she will see a taxi in the first 5 vehicles. Okay, first 5 vehicles. So calculate the probability she will see a taxi in the first 5 vehicles. Okay, again I'm going to use the reverse method to find out. Okay, so what if I have first time that she's seeing only on the 6th and onwards? What happens if she only sees on the 6th and onwards? If she sees only on the 6th vehicle and onwards, meaning there's no taxis, between 1 to 5. Okay, no taxis between 1 to 5. So no taxis between 1 to 5 inclusive, I and C. Okay, inclusive. Okay, so let's find that no taxi. So no taxi is 0.95, which is Q, and you have the first time that she's seeing only on 6th, so no taxi will be to the power of 5. Okay, so this is okay. We don't have to find the answer. Let's just, we don't have to find. But what is the complement of this? Okay, the complement of this is P 1 minus 0.95 to the power of 5. But what is the complement? If she is not seeing taxi, okay, 1 to 5, the complement of that is she's seeing taxi 1 to 5. So seeing taxi is first taxi, second taxi, third x equals to 1, first taxi, second taxi, and so on all the way to 5 trials. So every 5, first trial all the way to 5 trial inclusive, she's seeing a taxi. So to do that, I'm going to take 1 minus 0.95 to the power of 5. So taxis, okay, all first 5. Okay, all first 5. So from here we can figure out the answer is 0.2262. Okay. Okay, next C. Okay, C. Question C is calculate the probability that she is still waiting to see a taxi after she has seen 30 vehicles. So no taxi, basically she has seen 30 vehicles, no taxi in the first 30. Okay, she's still, the question here calculate that she is still waiting to see a taxi. Basically, even after 30 vehicles, she hasn't seen a taxi. Okay, she's still waiting. So no taxis first 30. Okay, basically no taxis at all. So Q to the power of 30. That's it. No taxi. Okay, if you write this down as a probability tree diagram, to see taxi 0.05, so no taxi 0.95. So basically you can just keep going 30 times. So no taxi, no taxi, that's what Q to the power of 30 is. So which is, this is same as 0.95 to the power of 30, and your answer is 0.2146. Okay, okay, and the last question D. Okay, last question D, and what do they want? D is evaluate the mode of X, i.e. what number vehicle is the most likely to be the first taxi that she sees. What number? Okay, well, if she's not seeing any taxi, okay, geometric probability is basically a trial. Okay, you are only finding the probability when you first see the taxi. Okay, when you first see the taxi. So in this case, taxi is it's a number, okay, which you can count. Okay, it's not something that you can measure. Okay, not like continuous. This is discrete, so which you can count. So if you can count, okay, the question here is what, evaluate the mode of X. So what is the number of X that you have to find? How many mode of X, i.e. what is the number of vehicle? What is the number of vehicle? How many vehicle that she has to see? She has to only see one. She only has to see one. Okay, so the number of, what number of vehicle is the most likely to be the first taxi that she sees? It's only one. Okay, so yeah, so that's it. I hope this is understandable. Okay, thank you.